Just finishing off section 3, the last problem that we did from last time. So this guy, where we wound up with a slope of 1/4 here with our reciprocal function, or our inverse function, sorry, the reciprocal slope. Notice in the last problem that the point 2, 3 in the original function has a slope of 4 at that point, but in the inverse function, so the point 3, 2, the slope of the graph is 1/4. So in the inverse function, you swap the x and the y coordinates. Once you've swapped the x and the y coordinates, the slope at that inverse function at that point is the reciprocal of what it was to begin with. So think of the pattern like this. If the slope of the original function f at the point x, y is dy over dx, that's just notation that we should be very comfortable with at this point. Then the slope of the inverse function at the point y, x is dx over dy. So I swap the x and the y, and it becomes y, x, that ordered pair, and then the slope is the reciprocal of dy over dx, or dx over dy. That's a good way to think of it. The way the book writes this is like this. dy over dx equals 1 over dx over dy. Basically what they're doing there is they're trying to show you that they're reciprocals. So if I take 1 over dx over dy, by doing leave it, change it, flip it, I wind up with dy over dx. I don't think that really does as good a job as explaining it like this does. So this is the one that I would like you to try to remember. Okay, this, if you can keep this straight, will keep problems like this straight in your head, and then you'll be able to do them without a function at all. So one more example. I am giving you the functions here. So we want to prove that the slopes of the graphs, well, I guess not prove, but show that the slopes of the graph of f and f inverse are reciprocals at each of the following points. So I'm giving you an ordered pair for f, and I'm giving you the ordered pair for f inverse, which is pretty easy, considering all you got to do is swap the x and the y. So we're doing basically two different problems here using the same two functions, f of x and f inverse of x. The inverse of x squared is the square root of x. So what do we need to do here?
Find the slopes.
Well, it says show that the slopes of the graphs of f and f inverse are reciprocals at those points, right? Okay. So find the slopes. What do we do? Takes the derivative. So the derivative of f prime of x is what? And the derivative of f inverse of x, f inverse prime of x equals what? 1/2 x to the negative 1/2. Is that correct? One over 2 square root x. Is that correct? Okay. So now what do we do? Okay. So plug this in. What do you get? Plug this in. What do you get? Are they reciprocals? Plug this in. What do you get? Plug this in. What do you get? 1/6. Are they reciprocals? Yeah. So obviously I picked points that were going to work out to nice numbers so that we could solve this problem quickly. But the idea is any ordered pair for this function, when you find the inverse, swap the x and the y, plug them into the derivative, and you will wind up with the reciprocal of what you had in the first place.